Hi everyone, Unit 3 Measurement, Section 1, Trigonometry. This is Chapter 2 in your textbook. So there's a curriculum outcome I want you to be aware of. Okay, so you will develop spatial sense and proportional reasoning. Specifically, you will develop and apply the primary trigonometric ratios, sine, cosine, and tangent, to solve problems that involve right triangles. Trigonometry is a branch of mathematics that studies relationships involving lengths and angles of triangles. In this course, our study will be limited to right-angled triangles. This branch of mathematics provides useful tools for us to use for indirect measurement. If we could measure the length of an object with a tape measure, hey, that would be easiest. However, it's not always possible. Trigonometry allows us to measure spans across lakes, heights of tall objects that we can't climb to the top of, and eventually even to model the rising of the tides or the time of day the sun rises or sets. Okay, that last part isn't until Math 30-1 though, so we have some time. Okay, the skills you learn here will transfer to science, especially physics. For now, the answers you obtain will be the final ones. Later on, these same steps will prove to be just the first few in a much larger math or physics problem. But you never start at the end, only at the beginning. Okay, so here's a checklist of things I need you to do for this section. So you need to do the trig pre-assessment. If you haven't, please press stop or pause and go back and do that. Make sure you show your teacher after. Okay, then there are 6 parts to this chapter. Okay, the tangent ratio, using the tangent ratio to calculate lengths. Then we talk about the sine and cosine ratios. Then we apply the sine and cosine ratios to calculate lengths. Okay, then we apply the trig ratios. Then we solve problems with more than one right triangle. Okay, and as per always, after you're done all the parts, you have a formative assessment, a curriculum review, summative assessment, and then a trigonometry quiz. Unit 3 covers Chapters 2 and Chapters 1, so you will have your unit exam after you finish the next chapter, so not on this one. Okay, so let's get started. Part 1, the tangent ratio. Okay, south-facing solar panels on a roof work best when the angle of inclination of the roof, that is, the angle between the roof and the horizontal, is approximately equal to the latitude of the house. Okay, so here, if we can picture the slope of a roof, so this would be the rooftop. Okay, this is the horizontal. So that's like the ceiling in the house. Okay, so the angle of inclination is that one. Okay, perfect. When an architect designs a house that will have solar panels on its roof, he or she has to determine the width and height of the roof so that the panels will work efficiently. In order to find this angle, we first have to name the sides of the right triangle in relation to one of its acute angles. Remember, acute angles are less than 90. Okay, so if we start from angle A, okay, the side straight across from angle A is called the side opposite A, or just O, opposite. Okay, the side right here, adjacent to A, adjacent just means beside, opposite means across from. So this is the side adjacent, or just A, opposite, adjacent. And of course, if we don't need this yet, but I might as well show you at the same time. Okay, the line CA is called the hypotenuse, or just H. Okay, so we can label these sides O, A, and H. Okay, awesome. Kind of a big deal. All right, the ratio, the length of the side opposite A to the length of the side adjacent A, depends only on the measure of the angle, not on how large or small the triangle is. This ratio is called the tangent ratio of angle A. The tangent ratio for angle A is often written as tan A, okay? And we usually write the tangent ratio as a fraction. Okay, so the tangent ratio. If angle A is an acute angle, so less than 90 in a right angle triangle, then tan A equals the length of the side opposite A divided by the length of the side adjacent A. So look, they put A up here in this triangle, so opposite is straight across from it, adjacent is right beside, and then the hypotenuse is always right across from the 90. Okay, that's a good way to memorize that. Okay, next. Excuse me. The value of the tangent ratio can be expressed as a decimal that compares the lengths of sides. For example, if tan A equals 1.5, then in any similar right triangle with angle A, the length of the side opposite angle A is 1.5 times the length of the side adjacent to angle A. So tan 1.5, all that means is that this side here will always be 1.5 times bigger than this side. So if we throw some numbers in, if this side is 10, well, 10 times 1.5 is 15, so that'll be 15. Okay, so that's one triangle. That would make this work. Okay, what if this side was 5? Well, 5 times 1.5 is 7.5. Okay, so the ratio just is an expression of how much bigger this side is than that side. Okay, really we can measure the tangent ratio of both angles in a triangle. Of course, depending on which angle you choose, the name of the sides changes. Okay, the angle you name the sides from is called the reference angle, and it's extremely important that you name the sides correctly from whichever reference angle you've chosen. Okay, so let's give that a try in example 1. So example 1, determining the tangent ratio for angles. Okay, determine tan x and tan z. Record your answer as a reduced fraction first, then as a decimal to the nearest tenth. Okay, so if I start from x, then 6 is the opposite, it's right across, and then 12 is the adjacent. Okay, we don't have to worry about the hypotenuse. We could put that in if I really wanted. Okay, now tan x. Okay, that is the side opposite, so that is 6 divided by the adjacent, which is 12. Okay, now of course 6 over 12, we can't leave it like that. We have to put it as a reduced fraction, so 6 over 12 is 1/2. Okay, so then tan x, so that's the reduced fraction, and then as a decimal to the nearest tenth, that's 0.5. Awesome. So now I'm going to write in orange just so you can see what's going on. Okay, if I want to find tan z, okay, well, from z, I have to relabel the sides. See, the 12 is the opposite of z, and the 6 is the adjacent from z. So if I'm looking at tan z, it is opposite, so 12 divided by 6. Okay, well that of course reduces to 2. Sorry, yeah, whatever. Okay, so that equals 2. Okay, so then of course as a decimal to the nearest tenth, that is 2.0. Okay, so again, when we label or when we figure out ratios from different angles, we have to rename the sides to make sure it all works properly. All right, next one. Okay, so you can use your calculator to determine the measure of an angle when you know the value of the tangent ratio. The tan minus 1 button, pronounced arctan, finds this angle. Okay, now before we even get to using our calculators, we need to make sure we're in the right mode. Because if you're not in the right mode, your calculator will give you wrong answers for all of these. Okay, so first things first. I'm going to turn this off. I'm going to go to my camera, and we're going to have a look at this. Okay. There we go. Okay, so on a TI-83 or 84, I need you guys to hit the mode button. Okay, and then the third one down says radian or degree. We have to make sure that we are in degree mode. So to switch modes, okay, so go down to the level that you want and then just scroll sideways So if I want it to be on radian mode, I would hit enter here. See how the choices turn black? Okay, so I want to be in degree mode, so I hit enter on that one. Okay, and now the answers, or my calculator will tell me the right stuff. This is an extremely important step because if you don't do it, your calculator will give you wrong answers for everything. Okay, and then you go second quit to get out of there, and now we're good to go. The last bit, okay, so the buttons we're going to use in this unit are sine, cosine, and tangent, and then arc sine, arc cosine, and arc tangent, the tan negative ones. So to access the arcs, these arc sine, arc cos, arc tan, we hit second first, and then say arc tan, so that's tan negative 1. It opens the bracket for us, and away we go. Okay, that is how we use the TI-84 for this. Okay, it's gonna time out on me here right away, so I'm gonna enter. Okay, to do the same thing on a TI Inspire. Okay, so here's the Inspire. We'll turn it on. Excuse me. Okay, so I'm going to make a new calculator page just so you can kind of see what's going on. So new calculator page. Okay, now hit the home button. Okay, so that's that guy right there. Okay, and then we want to go to settings, number 5. So hit 5. Okay, wow, it makes a nice bright menu. Come on, calculator, focus. Wow, okay, come on. There it goes. Okay, so we want document settings. So scroll down to the second one, document settings. Okay, and oh, look, that second one, angle. See, I'm in radian mode right now. So if I hit the tangent button or the tan negative 1 button, okay, my calculator would tell me all the wrong answers. So I'm going to scroll down to radians. Okay, so you can see that black bar around the thing. Okay, and then I'm going to hit sideways on it. And then I have 3 choices. So I have radians, degrees, and gradians. Don't worry about what radians and gradians are right now. But hit degree, press enter. And then what we're going to do is we're going to scroll down and we're going to make that the default. Okay, so hit enter, apply these to open documents and new documents and Scratchpad. Yes, we want to do that. So now we are on our in degree mode. Okay, so one last thing. So let's go to our current document. So we have, that's just the normal page. Awesome. Now, the trig buttons for TI Inspire users, if we go down to, where am I? There we are. Okay, so we have this trig button right here. Come on, focus. There we go, trig. Okay, so if we press, oops, timed out, sorry. Okay, so if we press that trig button, it opens a menu for us. Okay, let that focus again. Okay, so there's our sine, cosine, and tangent buttons, along with the arc sine, arc cos, arc tan. It's kind of sensitive, so okay, there we go. So we get our menus from that. This calculator also has these extra 3 buttons, which the TI-84 doesn't. We don't have to worry about those until Math 30, so I'm not even going to introduce them now. Okay, so sine, cosine, tangent. So if I want, say, tan negative 1, I'm going to hit that button, and then look what your calculator opens up. The arctan template opens the brackets, away we go. Okay, so we'll come back to that here in just a second. Okay, so determine the measures of angle K and angle N to the nearest degree. Okay, so they say angle K, so that's first, so I might as well start with that one. So from angle K, the 9 is the opposite. The 13 is the adjacent. Okay, that's just what those angles mean. So we're going to write this. Tangent K, or angle K, is equal to the opposite, so 9 divided by 13. That's great. Now we have to do algebra. If I want just angle K, it means I have to get rid of the tangent. Okay, and in algebra, we always use the inverse functions. So the opposite of tangent is arctangent, or tan negative 1. Okay, so tan negative 1, that's going to cancel off the tangent. So whatever I do to one side, I have to do to the other. So tan negative 1 of that side. So on our calculators, all we have to do, okay, so we have, okay, focus, there we go. Okay, so hit that trig button, okay, and then we want to arctan, so arctan, and it was 9, sorry, there we go. So it was 9 over 13, so focus here. So 9 divided by 13. We can close the bracket if we want to. If it's the last thing we write, we don't really have to, and boom. So 34.7 degrees. That is our answer there. If I try the same thing on the TI 83, 84 plus, so we want second tan, so tan negative 1, okay, and then 9 divided by 13. Hit enter. Oh, look, 34.7. Okay, awesome. So that is how we type those in for both of those. All right, so angle K then is 34.7 degrees. Okay, I'm going to write in blue again for the next one. Okay, so if I want, so now I want tan angle N. So tan angle N. Okay, so I have to rename the sides. So from N, 13 is the opposite and 9 is the adjacent. So tan angle N, excuse me, so is opposite divided by adjacent. So the opposite is 13, the adjacent is 9. Okay, and you just type that in exactly the same way. We use arctan. So tan negative 1, that cancels that one. And then arctan this guy, 13 over 9. And we end up with an angle of 55.3 degrees. Okay, one thing I want to show you guys right now because it's important. Okay, triangles always have 180 degrees. Okay, so because the triangles we're using here are all 90-degree triangles or right triangles, so 180 degrees minus 90 equals 90. All that means is that these two angles, K and N, have to add up to the remaining 90 degrees allowed. So, if we have a look at the two angles, 34.7 plus 55.3, hey, that works out to 90 degrees. It's perfect. Now, what that really means for us is we can figure out, if we just do trig once and figure out angle K, 34.7, we can figure out angle N by going 90 minus 34.7, because that'll give us the 55.3 degrees. Okay? It's just a little trick that we're going to use later on. Okay? All angles in a triangle add to 180 degrees. Okay, example 3. Using the tangent ratio to determine the angle of inclination. Clyde River on Baffin Island, Nunavut, has a latitude of approximately 70 degrees. The angle shows the side view of some solar panels. Determine whether this design for solar panels is the best for Clyde River. Justify your answer. Now remember, the angle should be close to the latitude of where the house is. Okay, so we want to figure out this angle, the angle of inclination of the solar panel. Okay, and it should be close to 70 to be ideal or proper. Okay, so how we do that, how we figure out this angle. So this is the side opposite, 70 is the adjacent. So we write down tangent of our angle. So let's call it alpha. This is the Greek letter alpha. We typically use Greek letters for the angles in triangles. So we can use alpha, we can use theta. Beta is another one. It's a B with a tail. Don't worry about what you use. You can use X as well. It's just in textbooks we usually give Greek letters. So tan alpha equals opposite over adjacent. So opposite is 208 divided by 70. Okay, if we put the units in, centimeters, centimeters, the units just cancel anyways. So not a problem. Okay, and then of course we have to arctan this. So that cancels. So then arctan that. So our angle, then when we type that in, works out to 71 degrees. Okay, so the latitude of Clyde River is 70, so we are very close. So this design is close to perfect. You know what? Instead of saying that let's just say is appropriate. Here, that would be better. So this design is appropriate for Clyde River. Okay, awesome. All right, next one. Okay, using the tangent ratio to solve a problem. Okay, a support cable is anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long. It is attached near the top of the pole. What angle to the nearest degree does the cable make with the ground? Okay, so if we draw this, here's our pole, telephone pole. Okay, so the cable is attached near the top of the pole. Okay, and we are anchored 5 meters away from the pole. 19. Remember, these diagrams are very rarely drawn to scale. Okay, so then I need this angle is what they're asking for. Okay, awesome. Well, the problem here is that the only ratio you guys know right now is the tangent ratio. Later on, we will do this with a different one, but that's okay. It kind of lets us show some other things. Okay, so if I want the opposite, because all I know is tangent right now, so opposite over adjacent, it means I need that side. Okay, so the idea is if we call that one x, because this is a right angle triangle, I can use Pythagorean theorem. Okay, so x squared, so this is backwards Pythagorean theorem because I'm figuring out a side. So it's 19 squared minus 5 squared. So the hypotenuse squared minus the other side squared. Okay, so, and let's go to the nearest tenth. So that works out to 18.3, let's see, meters. Okay, so this is telling us that the power pole is 18.3 meters tall. Now, the thing is, it's not 18.3. It's 18.330302778. Now, it's extremely important that we use all our decimals because the 18.3 is not our final answer. So I'm going to show you some really neat stuff on your calculator. Okay, first of all, though, let's figure out the tan ratio. So tangent of our angle, that's opposite divided by adjacent. So that's the 18.3 divided by 5. Okay, and then we're going to arctan, okay, that. So alpha equals arctan of 18.3 over 5. Now, I don't want you guys just to type that in. Okay, that's kind of a big deal, so please don't do it. Okay, so I'm going to show back to that. Working on my calculator screen. Okay, where are we here? Okay, there we go. Okay, so I'm going to show you guys. So this was 19 squared minus 5 squared. Okay, enter, then square root. Now, if I could type in 336 there, or on the Inspire, if we just use our pad here, and if I scroll up, look, I selected 336. If I hit enter, that populates my square root right there. That's not particularly helpful, that one, because 336 is pretty easy to type. Now, the next one, though, okay, I have to arctan, so arctan, so arctan. Okay, now I have to go 18.3 divided by 5. Now, I don't want to have to type in 18.3303070 027798. I don't want to have to type that in, so I just scroll up. Okay, hit enter. See, now I have all those decimals. Okay, then divided by 5. Okay, and that is a handy trick that we can use for this calculator, because I can scroll up and pick out any number I want, any number that I previously figured out. Okay, so now we hit enter, and that is the most accurate that we can make our calculator be. So we can try it without that, so just 18.3 divided by 5. Okay, and look at the difference. One is 74.74, the other is 74.71. Okay, the difference in the decimals is important, because what would happen if I was, say, rounding to the nearest, oh, we timed out. What would happen if I wanted to round accurately enough? Okay, so say to the nearest hundredth, you would get 74.74 for the first one and 74.72 for the second one. And of course, well, 74.74 is correct because we used all the decimals. You should only be rounding once for every question. Okay, now let's just really quickly show that on the TI-83. Okay, I'm going to time out here, so I'm going to start again. Okay, so TI-83, 84. Okay, so we have to do that, get our decimals back. So 19 squared minus 5 squared. Okay, great. Okay, so that's 336. So then we have to square root 336. Now, we can't just scroll up on the TI-83, 84s. If you have one of the newest ones with the latest operating systems, it might let you. So give it a try. If you can scroll up, then awesome. Okay, mine won't. Okay, so I just typed in 336, so I got that answer. Now look, I want to draw your attention. Oh, too far. Here we go. So calculator, I want to draw your attention to the negative button. Above the negative button, can I get close enough there? It's not going to focus. Above the negative button is the ANS. So that is, your calculator stores your last answer. So this 18.33 is stored in the ANS spot. So if I go second ANS or second negative, your calculator does that. So hey, look, that is 13.33 or 18.33, all the decimals. Great. So how we can use that is we go tan negative 1, okay, and we want that 18.33. So I'm going to go second answer. So that answer is 18.33 divided by 5. Now it's important for you to understand that 18.33 is only in the answer for one time, because as soon as I hit enter, okay, oh, 74.74. Now that is stored in answer. So you have to make sure you get it right the first time, because look, answer changes every time you hit enter. Either way, you should only need to do it once. So on the TI-83, 84, that is still 20 or 74 point to the nearest degree, so 75 degrees. Okay, I know that last example took a long time because of the calculator work, but trust me, it'll be nice for you just to know that. Okay, so we're done this part, so I want you to practice section 2.1. Starts on page 75 in your textbook. Okay, so make sure you show your teacher when you're done, and we'll go from there. See you next part. Thanks.